The Aurora Borealis, or the Northern Lights, are one of nature's most mysterious displays. In the past, people thought that these lights in the night sky were the souls of the dead, ghosts sending messages down from the afterlife to people awestruck on the ground beneath.
And you can sort of see why. There's something very spooky about all of this. But in some ways the excitement is figuring out the science behind the magic. And that itself is quite magical.
I'm Jim Wild, and I'm determined to unlock the secrets of the Aurora. Not just because they're mysterious and magical, but because they tell us something about how we're connected to what's going on in space. And that's going to become increasingly important to our way of life. If they're not ghosts, what are the Northern Lights? In this model, I've got tubes filled with argon gas, and I'm running an electric current through them, and it's making the argon glow. In the upper atmosphere, oxygen atoms are being bombarded by electrons from space, and that makes them glow. So the physics is just the same. It's amazing really, but under bombardment from space, the air that we breathe starts to glow. Nobody understands how the electrons collect so much energy on their way down to make the aurora. So if I'm going to figure this out, I need to collect more data. I need to go and find the aurora. But you don't usually find the aurora in Britain, we're too far south. Because the Earth's magnetic force field only guides particles down near the poles, to find aurora, I'm going to have to head north. One of the best places to see the aurora is Iceland, so I'm heading to the northern tip of a very northern country. To run an experiment like this, you need a strange combination of things. You need a dark field, a long way from buildings and towns, but I also need some power and some internet. But luckily I found a very helpful farmer, and I can use a bit of space in his land, and so we actually get really nice space physics in amongst the cows. This box is what I call my TARDIS. It's full of high-tech camera equipment and computers, and enables me to make really good measurements of the aurora. The camera's got a fisheye lens, so I can take a picture of the entire sky every few seconds, but I've got to make sure it's pointing straight up, so I get a proper image of the whole sky. Spot on. Okay, so that's taken a good image, so I will now just try and have a display of it and see what we can see. That seems to be working. We have a sharp image. That's good. The camera works, so I feel safe. I can stitch together pictures that are taken all night and make them into movies, which then show me a whole night's activities in a few seconds, which give me a really good record of when and where the aurora appeared. Tonight, well, at the moment I can see some really nice clear sky actually, and some wispy clouds. There's a breeze blowing it by, so could be good. I'm sitting here in a coal field in Iceland, waiting for the Northern Lights to come out. The sky at the moment is partly clear, partly cloudy, so there's some good gaps in the sky, so the clouds are leaving some windows that the aurora might peek through. Right now, can't see a great deal. I think the clouds come in a bit rolled in. It's going to obscure our viewing probably tonight. I don't think I'm going to see anything. so I think I'm going to give up, go to bed. I've got another field site, so I'm going to try there tomorrow and see if I can catch some Aurora. The Aurora are mysterious in lots of ways. Scientists for a very long time couldn't work out where the electrons that hit the upper atmosphere come from. Strangely, this great nighttime show is caused by the sun. Electrically charged particles pour off the sun and stream past our planet, and some of the particles get trapped by the Earth's magnetic field. So the stronger the wind blows, the better the aurora. So this link to the sun means that the aurora are a great barometer of solar activity and what's going on in space around us. And this really matters because giant solar eruptions that create great auroral displays also cause geomagnetic storms. And these have led to problems with communication systems and navigation systems and can also wipe out power grids. There's a risk that an electromagnetic tsunami could really interfere with our high-tech society. So by studying the aurora, I can understand space weather better and help us protect against storms in the future. This is my second observatory. By having two different sites, I get two different views of the night sky, and it means if one site's cloudy, then the other site might be clear, and increases my chance of actually catching the aurora.
At the moment the sky is looking a little bit cloudy, there's some cloud around. I need to check some other things as well, because it's obviously not just down to clouds. So I've been checking out the activity in space. So images of the sun from the day before yesterday are showing that there are these active regions, these really bright regions, and they actually fired out some material, so this pinged out like a catapult into space, and that's actually heading towards the Earth. So this material, when it gets to the Earth, could cause the aurora. We've got other spacecraft, some sentinels that sit upstream of the Earth, so they're getting advance notice of everything coming our way, and they're showing that at the moment the solar wind is looking quite good for generating aurora. So everything's ready, just waiting to see what nature does now.
I think that's aurora up there. Yeah, it's arriving over there, just near the horizon. So there it is. Excellent. Oh, that's brilliant, yeah. This is a really good show tonight. I'm going to get some really good data, I think. I compare those measurements to data from satellites that are flying over the aurora. Ripples in the Earth's magnetic field are energising electrons and firing them in towards the Earth. It means I might have found the elusive energy source that powers the aurora. It's really weird because I'm trying to figure out what's making that light in the sky, what's making the aurora. And it's not like when you figure out a magic trick, it suddenly seems less impressive. Looking at the aurora, you know, it's more impressive when you figure out how it works. It's kind of more magical. Whenever I get to see a good auroral display like this, it makes me think about the old stories that the Northern Lights are messages from another world. And there's something in that really, because the Northern Lights are telling us about our connection to space. They're bringing messages from the sun, and those are messages that we need to listen to.